Here's an example of a deed and a problem to do with it. So first it says to sketch, okay? After we read the description, I want you to pause the video a little bit and try to sketch this. It's not that easy to do the first time, but you'll get used to it. And then you'll see what I do for a sketch. Sketch and find the area of the described plot. So the deed would read, from the granite post, so we have to have a starting point for a deed. Keep in mind when you're writing your deed, you have to pick a starting point. So from the granite post, and in your deed, you might want to be more specific than the granite post. The granite post at the corner of such and such, or the large tree at such and such a GPS location, et cetera, all kinds of different things that you could use as a starting point. So from the granite post, proceed 195 feet east, there's your direction, along Edgewood Avenue. Then along the bearing of south 32 degrees east for 260 feet. So our links get longer, so we better start the short side here, kind of. Then along a bearing of south 68 degrees west for 380 feet, and then straight back to the post. Now, keep in mind when you're writing your deeds, you never define the last line in the deed. We'll talk about that in class. Ask me about that in class. That's an important little detail when you do your deeds. So these lines are 195, 260, and 395. They get longer as you go. Why don't you pause the video and try to sketch the plot. And while you do that, I'm going to share to a screen, to a sheet of paper so I can work on it. All right, so we're going to call this Edgewood Avenue. Edgewood Avenue plot. Okay, so granite post, GP. I'm going to go 195 feet due east. It's like traveling left, 195. Make it a little bigger. Okay, then we have to travel south 32 degrees east. So draw a north-south line. 32 is going to look like this, 32. South 32 degrees east, so we have to go east of south 32 degrees. And we're going to draw another line. Make this one longer because it's 260 feet instead of 195. And knowing that this measurement here is 32. Okay. Then we get here, I'm going to draw another north-south line. I always do that. And we're going to go 385 feet south, 68 degrees west. So 68 degrees west of south. That's going to be something like this. This line's really long because this was 260. And this one's 385. It may not even be long enough. I'm running out of paper, so we're just going to call it. And then it says go straight back to the granite post. So here's your sketch of your property. Should look something like that. Knowing that this is 68 degrees. Now you also know, because these are parallel lines and these are also interior lines, you also know that this angle is 32 degrees. And that means that this angle, these three have to add up to 100. So 32 and 68 is 100. So this angle is 80 degrees. All right. Now, we're going to break the shape into two pieces. You can break it this way if you want to, or you can break it this way. I'm going to choose to break it this way. Just looks a little, you got to just get to decide on something. So that's what I'm deciding on. If you broke it this way, the problem would come out differently, but your totals are going to be exactly the same. And we need to find the area of this and the area of this. So let's work on the area of this piece first. So if that's 32 degrees, this is 90 degrees. So this whole angle is 122. All right, so there we have a side, an angle, and a side. So area A is going to be equal to 1/2 of 195 times 260 times the sine of 122. And if you put that in a calculator, that comes out to be 21,498 square feet. Okay, so that's the area of that smaller triangle. This triangle is going to be bigger, right? It looks bigger. It is going to be bigger. So in order to do this triangle, the only piece of this triangle that we actually have right now is this 385. This 80 isn't actually in that triangle. It's in both triangles. So we need an angle here, and we need this side. So in order to get this side, we're still going to work in triangle A. We're going to use law of cosines. We're going to get the side that's opposite this 122. I'm going to call that D. I'm going to use black for that. I'm going to call that side D. So D squared is going to equal 195 squared, just using law of cosines here, 260 squared minus 2 times 195 times 260 minus cosine of the included angle, which is the whole thing, 122. And D, using a calculator there, D comes out to be 399.20. It's like 0.1 something, but it comes out 0.20. So I'm going to mark that 399.2. Okay, so there's D. Now, we also need this angle. Now, in order to get this angle, we're going to first get this angle. And that, I think we can use law of sines for. Let's call that x. So sine of x is opposite 195. And sine of this 122 is opposite the side that we just calculated, 399.2. And when you do that, x should come out to be 24.5. So if x is 24.5, then the angle we're looking for here is going to be 80 minus 24.5, also known as 55.5. And then we can do law of, well, not law of cosines, but the area formula on this other triangle, which I'm going to call B. Let's see, call that B. So area B is equal to 1/2 of the two sides that we have. We have 385 times 399.2 times sine of 55.5. And B winds up equaling, when you do that calculation, B winds up equaling 63,330.8. We'll just call it 63,330. So the area here is 63,330. And the area in the triangle A, the blue triangle, was 21,498. So the area of the whole thing, the area of the entire shape, is the sum of those two things, which is 84,820 square feet. Now, if you want to go to acres, you need to divide by 43,560, because there's 43,560 square feet in an acre, and you wind up at 1.95 acres. And that's a nice deed problem done out. You're going to be doing your deed of your property, labeling out the different things and writing the deed as well as a sketch and finding the area.